All right, 8th graders, this video is to help you with question 7 on your second CR. It says, consider the following patterns: 720, 243, 81, 27, 9. And then they want us to continue on with the pattern. They give us, we have to continue on and get 1, 2, 3, 4, 5 more numbers that follow that pattern. And they want you to take a look at 3 to the 6th, then 3 to the 5th, then 3 to the 4th, then 3 to the 3rd, then 3 to the 2nd, and then get 1, 2, 3, 4, 5 more in that pattern. Complete each pattern. What is the connection between the two patterns? Come up with a rule about exponents that explains the pattern. All right, so I'm going to do a few things. I like things in table form. It just happens to be who I am. So I'm going to write exponential form. And I'm going to look at my second pattern first. I know this is so ugly. My handwriting's not the best. Oh, well, we got to get over it. And then I'm going to do expanded form. And then I'm going to do standard form. Okay. So if I take a look at this second pattern in exponential form, we had 3 to the 6th, then 3 to the 5th, then 3 to the 4th, then 3 to the 3rd, then 3 to the 2nd. And now I have to do 5 more. Great. Didn't leave quite enough room. Now I have to fill in 1, 2, 3, squeeze in 4, 5 more. So, first of all, for this second pattern, I think I see a connection already before I even work any of this out. See how this is 3 to the 6th, then 3 to the 5th, then 3 to the 4th, then 3 to the 3rd, then 3 to the 2nd. It seems like my exponent is just going down by 1 every time, so I'm going to keep rolling with that. So after 3 to the 2nd, it would be 3 to the 1st. Drop it down 1 more, 3 to the 0, 3 to the -1, 3 to the -2, 3 to the -3. So it just seems as though as I'm working down my table, the pattern went 6, 5, 4, 3, 2, 1, keep going down, 0, -1, -2, -3. Let's take a look at some of these in expanded form. 3 to the 6 means 3 times 3 times 3 times 3 times 3 times 1, 2, 3, 4, 5, 3. Whew. Now I'd have to multiply that together. 3 times 3 is 9. 3 times 3 is 9. 3 times 3 is 9. Okay. 9 times 9 is 81. So I have to do 81 times 9. I don't know what that is. So I'm literally multiplying all these 3 together so I can get to standard form. 9 times 1 is 9. 9 times 8 is 72. Okay. So I get here 3 to the 6th as being 729. I hope I didn't make a mistake. Alrighty, bro, that's what I get. But I'm looking at the top pattern, I'm like, well, that's not helping me. Oh, well. Let's try 3 to the 5th. There could be a misprint here. Let's try 3 to the 5th. 3 to the 5th means 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. 3 to the 5th. All right, 3 times 3 is 9. 3 times 3 is 9. And then I have to multiply by 3. So now 9 times 9 is 81. 81 times 3. I don't have a calculator at home. If you want to do 3 to the 5th on your calculator and just get me to an answer, that would also be fine. 3 times 1 is 3. 3 times 8 is 24. Okay, this is what I expected to be happening. I expected, like, when I figured this out, it would be the second one in that pattern. So this is 243 is 3 to the 5th. Let's do 3 to the 4th. 3 times 3 times 3 times 3. That's 9 times 9. That's going to get us to 81. Yes, I think this is a misprint. Or I did something wrong with my multiplication, but I think this is a misprint. I think this should say 729 instead of 720. So just change that. And then 3 to the 3rd means 3 times 3 times 3. That's 27. 3 to the 2nd means 3 times 3. That's 9. Excellent. 3 to the 1st just means 3. So that answers 3. So now you're going to notice the pattern going down this column. How do I get from 729 to 243? How do I get from 243 to 81? How do I get from 81 to 27? Work down the column. How do I get from 27 to 9? How do I get from 9 to 3? Well, guess what? 729 divided by 3 will get you to 243. Because 6 to 5, I have 1 fewer factors of 3 there. 243 divided by 3, check it on your calculator, will get you to 81. 81 divided by 3 will get you to 27. 27 divided by 3 will get you to 9. 9 divided by 3 will get you to 3. So guess what the next one will be? Down this column, just keep dividing by 3. That's this pattern. Divide by 3, divide by 3, divide by 3, divide by 3, divide by 3. So now if I divide by 3 again, 3 divided by 3 is 1. So guess what 3 to the 0 power is? It's really 1. You're going to learn about that if you haven't already. Now I have to do 3 to the negative 1 power. Well, if I keep going down my table and I divide 1 by 3, if I have 1 divided by 3, I can write that as a fraction. I can write that as 1 over 3. 1 divided by 3, division is your fraction bar. So guess what 3 to the negative 1 is? It's 1/3. Negative exponents turn out to be fractions. Let's try right here. Let's divide 1/3 by 3. Just got to down these numbers, just keep dividing by 3. So if we have 1/3 divided by 3, keep the first fraction. This 3 is the same as 3 over 1. Change your division to multiplication and flip over that second fraction to 1/3. Straight across the top, straight across the bottom is 1 over 9. You're going to be learning about negative exponents soon if you have not already. So this is actually 1 over 9. And 3 to the negative 3, if I take 1/9 and divide by 3, 3 to the negative 3, if I take 1/9 and divide it by 3, that's 3 over 1. Keep the 1/9, change your division to multiplication, and flip over that second fraction to 1/3. Straight across the top, straight across the bottom is 1 over 27. So this one's 1 over 27 squeezed in at the bottom. All right, so here's the deal. This one, 3 to the 6th, 3 to the 5th, 3 to the 4th, 3 to the 3rd, 3 to the 2nd, 3 to the 1st. This is a long video, sorry. Then it would go 3 to the 0, 3 to the negative 1, 3 to the negative 2, 3 to the negative 3. And up here, this is the pattern in the top set. 729, 243, 81, 27, 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. 1/9 divided by 3 is 1 over 27. What is the connection between the two patterns? All right. Connection between the two patterns, they actually represent the same numbers, just written in a different form. That's the connection. So the connection between the two patterns, they represent the same number written in different forms. Like 729 is standard form, but it means the same as 3 to the 6th. So your first term is actually the same number written in a different form. 243 is standard form, but that's the same number, as 3 to the 5th. And 81 is 3 to the 4th, and so on. So the connection is they actually, each term in each one of these patterns represents the same number in two different forms. 9 is the same as 3 squared. 3 is the same as 3 to the 1st. 1 is the same as 3 to the 0. It means the same number. 1/3 is equal to 3 to the negative 1. Come up with a rule about exponents that explains the pattern. Both patterns represent powers of 3. Not exactly sure what they're asking for. Come up with a rule about exponents that explains the pattern. Both patterns are powers of 3. I don't really, question part C, I'm just not sure about the wording. Come up with a rule about exponents that explains the pattern. I guess I could do, 3 to the n? I have no idea what they want to do. These are powers of 3. So you might want to check with your teacher about what that means. Longest video ever. So sorry. Hopefully you pressed pause and worked it out yourself when you got to the point that you understood.